This lesson is for Mrs. Cucci's College Now Pre-Calculus class. We are on lesson 6.5C. So if you want to go ahead and get your notebook out, we'll continue on with this lesson. Okay, so the next example I want to look at is sine x plus cosine x equals 1, and we're going to solve it on the interval from 0 to 2 pi. Okay, so if you notice, what I have here isn't factorable. There's no GCF. I'm not really sure what to do with it. So what I'm going to do is I'm actually going to manipulate both sides of the equation so that I can get it to be something that I can work with. Okay, so what I'm actually going to do here is I'm going to square both sides of this equation. Pardon me. And now we're going to go ahead and multiply this out. Got one of them here. Okay. Combine my like terms. So that we get this. Okay. And if you notice, something winds up happening here. We're always looking for identities. Okay. So if you notice, we've got sine squared theta, or sine squared x plus cosine squared x. Well, I know that that's the Pythagorean identity, and that it equals 1. Okay. So I have 2 sine x cosine x plus 1 equals 1. And 2 sine x cosine x is also an identity. That's sine 2x. Alright. So what we're able to do is we're able to simplify this out so that we get sine of 2x equals 0. Okay, so now here comes that trick again when we're dealing with the double angle identities. Originally, our interval looked like this. Okay? But since we're doing the double angle, we're going to switch it so that it goes between 0 and 4 pi. Okay? So, now we need to decide where is sine equal to 0. Okay? So if I think about my unit circle, sine is equal to 0 at 0 and pi. But remember, 0 to pi is one full rotation, 0 to pi to 2 pi, okay, 0 pi, 1 pi, 2 pi, this is going to be 3 pi, and then back again at 4 pi, alright? So what I need to do now, because remember this is when it's 2 times the angle, we need to go through and divide each of these by 2. Okay. Now, we are not going to include this 4 pi because if we remember, we've got our less than, not less than or equal to, so this piece gets rejected. And we get 0, pi over 2, pi, and 3 pi over 2. Okay? And you do want to make sure that you check these out and see that they all work. And we can check those directly back into my original. So we're going to do the checks right over here. I'll switch color for that. Okay. So I've got sine of 0 plus cosine of 0 equals 1. We know sine of 0 is 0, cosine of 0 is 1, so this one checks. Okay, that checks. Pi over 2. Sine at pi over 2 plus cosine of pi over 2 equals 1. Sine of pi over 2 is 1, cosine, and we get 1. So that one checks. Pi. Sine at pi, which we know is 0, plus cosine at pi is negative 1. That gives us a negative 1. So that's not going to check. And last but not least, we've got sine at 3 pi over 2, which we also know is 270 degrees, plus cosine at 3 pi over 2. This gives us negative 1 plus 0. And that's going to equal negative 1, so that's not going to check either. Okay? So our only two solutions for this are 0 and pi over 2. Okay, so let's do another one with a double angle identity. Okay, so our next example is we're going to solve cosine 2x plus sine x equals 1, and we're going to be on the interval from 0 to 2 pi to begin. Okay, so cosine 2x is one of our identities, so let's do one where we actually use the identity. And the reason I want to use this identity is notice I'm dealing in terms of both cosine and sine. I have an identity for cosine 2x that will allow me to take this equation, put it all in terms of sine. So I'm going to use that one. So cosine 2x is the identity 1 minus 2 sine squared x. And we have to add on our plus sine x equals 1. Okay, so what winds up happening is I have a 1 on this side, 1 on this side. Negative 2 sine squared x plus sine x equals 0. And notice we don't have a double angle anymore, so we can keep our interval. We can pull out a GCF. And then use zero product rule. Okay. So I know sine is 0 right off the top of my head, thinking about the unit circle, at 0 and pi, also at 2 pi, but again, we're not including it. And sine is a half at pi over 6, but also, remember, we're in two quadrants here, so pi minus pi over 6, 5 pi over 6. Okay. So, our solutions are 0, pi over 6, 5 pi over 6, and pi. Okay, we're going to take a look at one more. Okay, tangent squared x plus secant x minus 1. So if you notice again, we've got an equation in two different trig functions, and I would prefer to have it in one if I could. So we look to see if there is an identity that can be used, and if we look at tangent squared x, we actually have an identity that's written in terms of secant that we can substitute in. Tangent squared x is equal to secant squared x minus 1. So I can use that in substitution so that I can get everything written in terms of secant. Okay. So now we're just going to combine some like terms so that we have this trinomial. So trinomials, generally we try and factor. If it's not factorable, we use the quadratic formula. In this case, it is factorable. And we know we're going to use 2 and 1. So now it's just figuring out what's going to go where. Larger value has to be positive, so secant, we want this to be a plus and this to be a minus. Zero product rule. Okay. And this is what secant equals. We can very easily change this to its reciprocal function, cosine, by taking the reciprocal of each side. Okay. Oops, my apologies. The reciprocal of 1 is 1. Sorry about that. Okay, so when is cosine equal to 1? When we're on the interval from 0 to 2 pi. We know cosine is equal to 1 at 0 and 2 pi, but since we can't use 2 pi, we're going to exclude that. Cosine is equal to a positive 1/2 at 60 or pi over 3, right? So that's your reference angle. We want where it's negative. So we're talking about the second and the third quadrants. Quadrant 2 is going to be pi minus pi over 3. Quadrant 3 is going to be pi plus pi over 3. Again, you're going to want to make sure you use the common denominator. So 3 pi over 3 minus 1 pi over 3 is 2 pi over 3. And 3 pi over 3 plus 1 pi over 3 is 4 pi over 3. Okay. So my solutions are 0, 2 pi over 3, and 4 pi over 3. And I lied to you. We have one more example. Sorry. Okay, so here's our last example. We've got sine x minus cosine x equals cotangent x. And we're actually going to take a look at this graphically instead of algebraically. So what I'd like you to do is go ahead and insert a graphs page into your calculator. And we're going to look at this two different ways. We're going to look at it as two separate equations and then finding the intersection points. And we're also going to look at it in terms of when we take the equation and set it equal to 0 and then look for the zeros of the equation. Okay? So since we would like our answers in radians, we need to make sure that our calculator settings are in radians. So you're going to go to Menu, Settings. We're going to change this graphing angle to radians. And I also would like float 6. Okay? Float 6 is going to give you more decimal places. And then let's make that default. So first one, we're going to enter sine x. And everybody should be doing this, not just me. Minus cosine x. I'm going to graph that portion. Control G to bring up my graphing utility again. And we're going to graph cotangent x. And this calculator will graph cotangent for us. We can go ahead and do that. Okay. So now we're on the interval from 0 to 2 pi. So we can go ahead and double click and adjust. We would like 0. And I would say maybe my y maximum, let's make that 3. And we want this to be 2 pi, and we can put in 2 pi. And then we want this to be negative 3. Okay. So if you want to take your labels and move them around, feel free. I know I don't like to have them sitting on top of my intersection points. It just makes it difficult to see. Okay. So we see our two solutions. We see them quite nicely. Okay. So what you're going to do to find your intersection points, Menu, Geometry, Points and Lines, Intersection Point. Click on the cotangent function and then on the sine minus cosine function, and those two will pop right up. And again, you're looking for the x value. So we've got 1.12765 and 5.66136. Okay, so that's one method to do this. Very quick, simple, easy to find those values. We can also do this. We're going to insert another graph page. If we were to take my equation and set it equal to 0, so we would have sine x minus cosine x minus cotangent x. Okay, hit enter to graph it. And again, we'll have to adjust our window. And this time what we're looking for are the zeros, where it crosses the x-axis. So menu, geometry, points and lines. And you can use point on for this. Generally, that's what I like to use. And all you have to do to use point on is you click on the line and I hit enter. And then you grab this point and you drag it, and it will say 0 when you get a 0. Okay, 1.12765, which was our same solution from last time. You grab it and move it over to this side, and you get 5.66136. Okay, so either one of these methods is appropriate for solving graphically. All right, that's it for today, guys. Thank you very much. If you have any questions, please make sure you jot them down and ask them tomorrow at the beginning of class.